Hello young researchers and the honorable juries. I am Muhammad Lingga Padantya Junaedi and my partner
Aqila Razzan Setyovianto from MTSN 1 Malang City. In this video, we are going to tell you about our research in Indonesian Science Project Olympia 2022. Assalamualaikum warahmatullahi wabarakatuh.
Fresh milk is a household commodity that is highly needed by society in Indonesia. However, due to the infection of trypanosomiasis pathogen, which is spread by Stomachus calcitrans flies, dairy cows have decreasing milk productivity.
In addition, the hot environmental conditions also make dairy cows feel stressed that will decrease the milk production compared to low temperature conditions.
Previous researchers have made innovation to prevent Stomachus calcitrans bite and to control heat stress in dairy cows. However, these innovations are relatively expensive, not environmentally friendly, and only have a single function in one device.
Based on these problems, we made an innovation entitled Zebra Clock First Generation, a Stomachus calcitrans bite preventer and automatic body temperature controller for dairy cow.
The honorable juries, the objectives in this research consist of: first, to determine the working principle of Zebra Clock First Generation, a Stomachus calcitrans bite preventer, and dairy cow's automatic body temperature controller.
Second, to determine the technical feasibility of Zebra Clock First Generation.
And finally, to find out the potential and advantages of Zebra Clock First Generation compared to previous technologies.
In this study, we use ADDIE method, which consists of analysis, design, development, implementation, and evaluation. We carry out this research at the researcher's home and the science laboratory of MTSN 1 Malang City from November 2021 to February 2022 by following strict health protocol.
The first stage is analysis. We analyze the flash vision when looking at zebra patterns, the effect of heat stress conditions on the dairy cow's body, and analyze the weaknesses of previous innovations.
In design stage, we made the working principle, electrical system design, and physical design of this innovation.
In the development stage, we made the bite preventer and body temperature controller in one device only. We also test 4 various thermoelectric circuits with 4 various input voltages. The best variation from those tests will be used in this technology.
In the implementation stage, we carry out several tests, referring to some previous studies to determine the effectiveness of the technology that we have made.
And the last stage is evaluation. We evaluate the system and the overall performance of Zebra Clock First Generation. The evaluation that we assess are effectiveness, price, usability, and performance of the device compared to other innovations.
There are the tools and materials that we use.
And these are the results of our study. There are 2 working principles in this research. Firstly, as a cow's body temperature controller, we use thermocouple type K as a sensor to monitor the cow's body temperature. When the cow's temperature is above 30 degrees Celsius, the sensor will send data to the temperature controller.
Then, it will give order to thermoelectric as the actuator to active and begin cooling cow's body through the copper plate. If a cow's body temperature is below 30 degrees Celsius, this technology will turn off automatically. Based on Frazi et al., the use of a body cooler can prevent a reduction in milk production from 224 kg per cow to only 92 kg milk loss per cow.
Secondly, as a Stomachus flash bite preventer, Zebra Clock First Generation uses a zebra skin pattern that will distract the flash view. This is because, based on how et al., the zebra pattern can create a powerful illusion and a wheel wagon illusion, which distract the flash view, so they cannot land easily on the cow's body.
On the other hand, based on the results of the output electric current and power test, the full parallel thermoelectric circuit has an electric current of 2.6 amps at a voltage of 12 volt and a power of 31.2 watts.
We also found that this full parallel thermoelectric circuit also shows the best performance compared to 3 other circuits and 3 variation voltage input. It was able to maintain the temperature below 30 degrees Celsius from first minute by 19.3 degrees Celsius until 10 minutes by 24.9 degrees Celsius.
According to Aziz et al., the electric current flowing in the thermoelectric is proportional to the cooling ability of the thermoelectric.
To extend the cooling system, we use a copper plate on a full parallel circuit as the best circuit that we tested before. We use copper because based on Fauci, copper has the second highest thermal conductivity of 401 watt per square meter Kelvin.
Based on the result, the thermoelectric temperature increased when it compares to the test without copper at a temperature of 25.7 degrees Celsius and was stable at the 10th minute at 29.4 degrees Celsius. It can be seen from the graph of the heat distribution at 1, 5 and 10 minutes that there was no significant difference in temperature on radius A to D.
The overall use of power in the device using the best circuit only requires 31.64 watt-hours, with estimated daily electricity use of 0.758 kilowatt-hours, and only needs about 1,000 rupiah for each device.
Compared to the previous 10 innovations, our device is more outstanding because we designed to combine stomach cyst bite preventer and temperature controller in one device only.
We also use environmentally friendly and energy efficient components, with the manufacturing cost per device of only 466,000 rupiah. This is relatively affordable for farmers in Indonesia.
Based on these results and analysis, there are several conclusions. First, Zebra Clock first generation is able to work automatically as a stomach cyst calcitrans bite preventer and body temperature controller.
Second, a full parallel circuit with an input of 12 volt that has a stable temperature which is appropriate with dairy cow's body. The best circuit with copper plates can decrease the temperature up to 25.7 degrees Celsius at the first minute and increase only to 29.4 degrees Celsius at the 10th minute, and the overall power consumption of the device was 31.64 watt-hours.
And finally, Zebra Clock first generation is more outstanding than previous technologies, which are more durable, easy to clean, work automatically, and relatively affordable. There are suggestions for further research.
And these are the references, also a documentation from our research. Thank you for your attention. See you in our next project. Wassalamualaikum warahmatullahi wabarakatuh.